Hi everybody. I am going to go through lesson 14 with you today to make sure that everybody stays on track, and we are going to continue straight on. Before we go there though, I do have a couple things. You should have the two handouts from the front table, your menu math folder, and a pencil. And block 1, please make sure that you put the cool down from yesterday in the block 1 inbox. I know Ms. Hancock announced, and I also put on remind that I fixed the video from yesterday pretty early in the day, yesterday morning. So you had the opportunity to do it last night. If you did not do it for whatever reason, please make sure you do that tonight, and you bring in your cool down and put it in the inbox tomorrow morning. Also, Carly, Nick, Victor, Jude, and Brianna, outstanding job on Dreambox. You guys had a lot of lessons. I know that you had the entire block to work on it because of the video going down. So I do appreciate you guys taking that time and truly working in Dreambox. Nice job. Block 2, also nice job yesterday. A lot of you had 6+ lessons. I thank you very much. And block 3, Liz and Summer, very nice job in Dreambox. But overall, block 3, you left my classroom a disaster. There were computers and headphones all over the place, and you all know better. So make sure that you're cleaning up after yourselves and putting your supplies away. Miss Willie called me yesterday afternoon and told me what my classroom looked like, and I was a little disappointed because I know that you guys know how to clean up. All right, let's get started on the lesson. There's a lot of information that I'm going to give to you. It's really just practice redundancy, but if you have to pause the video for any reason, please make sure you do so. I am going to go a little fast just because the video has to be under a certain amount of time in order for me to upload it onto YouTube. So I am going to go fast. So if you need to, make sure you are pausing this video and going through step by step each problem. Let's start with your warm-up. So, is the equation true or false? We know that if we have an equal sign, in order for it to be true, both sides must be equal. And this is bringing back to our exponent laws. So the first thing I notice here is that I have 10 to the 5th and I have 10 to the 4th. And I know that if I have same base, I need to add their exponents. And right away I notice that they multiply their exponents. So I'm going to say right off the bat that this one is false. For number 2, same idea, quotient rule for exponents. 10 to the 6th divided by 10 to the 4th means that I would subtract my exponents. And then again, quotient just means divide, so I would have 7 divided by 2. So this one makes sense that this would be 7 divided by 2 times 10 to the 6 minus 4. So I'm going to say this one is true. And last but not least, the first thing that I saw was this 3 times 2. And normally, if I have 3 times 2 with a power of 10, that's a power raised to a power. And I don't see that anywhere. My assumption here is that they took this 2 and they tried to distribute it here to the power of 10 as well as to the 8 and 4/10. So I'm going to say this one is false. All right, so we are going to do an example together. I'm going to walk you through the process of what it means to divide scientific notation expressions, and then we will do a whole bunch of practice in real-world situations. So the reason that we use scientific notation is for large numbers, and large numbers in populations or planets or bacterias. It could be really small numbers if I'm dealing with like bacterial masses and all of that. So how many humans do you think there are for each dog in the world? So if I'm looking at that question just in general, I would have a certain number of humans, a certain number of dogs, and in order to figure out how many humans to each dog, I would do what operation? Hopefully you're thinking divide. So I need to find the amount of humans and divide it by the amount of dogs, and that would tell me how many. So if I'm looking here, I have that there is an estimated 7.5 times 10 to the 9th humans and 6 times 10 to the 8th dogs in the world. So if I'm going to divide those two things, I have 7.5 times 10 to the 9th divided by 6 times 10 to the 8th. And here is where our exponent rules are going to start to play in. We're going to look at what the coefficients are doing. So really, I can break this expression apart into two different areas. I have my coefficients being divided, and then I have my powers of 10 that are being divided as well, which we know here we have the exponent rule that we subtract our exponents if they have the same base and they're being divided. So I would have 7.5 divided by 6, which 7.5 divided by 6 is 1/2500 times 10 to the 9th divided by 10 to the 8th. So I would just subtract those exponents, which would be 10 to the first power. And then I'm going to actually transfer that. So how would I write 1/2500 times 10 to the first power? I would just move that decimal 1 over, and that would be 12.5. So there are roughly 12.5 humans for each dog. So this is the process that we're going to go through. I'm going to give you a couple examples. I'm going to do with you in activity 1 and activity 2, and then activity 3 I'm going to have you do on your own, and then there will be a cool down. So our learning goal for the day is we're going to multiply and divide with scientific notation to answer questions about animals, careers, and planets, which are common areas where scientific notation is used. So in activity 1, we have a table, and we are going to compare different creatures on the planet. So we have humans, cows, sheep, chickens, ants, blue whales, krill, zooplankton, and bacteria. So which creature is least numerous? Well, if I'm looking for the creature that is least numerous, I'm looking for the least number of that creature. And if I'm looking at the numbers under the number column here, I'm going to look at their exponents first, and right away the one that's going to stick out is the one that is the lowest exponent, which would be blue whales. Since I know that blue whales, are the least numerous, it says to estimate how many times more ants there are. So if I'm looking for ants, these are the two that I am working with. So how many times more ants are there than blue whales? I can tell you a big clue when we're working with scientific notation and we're working with dividing and multiplying and all the different operations within scientific notation. If it says how many more times, immediately your brain should think divide. Divide those two numbers. Estimate how many times more ants there are than blue whales. So ants were 5 times 10 to the 16 over 4.7 times 10 to the third. Also notice this word in here, estimate. So I do not need an exact number, and if I'm looking at this problem to make it really easy, I could probably round that bottom number up to 5, and I could do this problem pretty quickly. So I'm going to estimate the bottom one. So ants would be 5 times 10 to the 16th. I'm going to estimate blue whales as 5 times 10 to the third. And then I'm going to break it apart like I did previously. So I have my coefficients, and then I have my exponents, and then from there, 5 divided by 5, oops, sorry about that, 5 divided by 5 is 1, times 10 to the 16 divided by 10 to the third, 16 minus 3 is 10 to the 13th power. So if I was to work that out, that would be there are 10 trillion times as many ants as blue whales. Answering the question, showing my work, and just pulling it apart as I go. Number two, which creature is the least massive? So least massive, looking at mass of one individual. So I'm going down and seeing which one is the least massive. So I'm going to look for the exponent that is the least number, which here tells me that bacteria is the least massive. And again, it wants me to estimate how many times more massive a human is. So I'm looking for where a human is massive, which is here. And I am going to, how many times more tells me to divide. 6.2 times 10 to the first divided by 1 times 10 to the negative 12th. This one's a pretty simple one to do with pulling it apart because I am dividing by a 1, which leaves my number alone. And then I have, again, my exponent rules over here. So 6 and 2/10 divided by 1 is just 6 and 2/10. And then exponents being subtracted, 1 minus a negative 12 turns it positive. So that would be times 10 to the 13th power, which is about 60 trillion times more massive. So humans are about 60 times trillion more massive than bacteria. All right, so we are going to change it up a little bit. So these are the simple division problems where you are just taking two pieces, estimating how many times more something is, and dividing it. Number 3 adds in another piece. So if you look at number 3, which is more massive, the total mass of all the humans or the total mass of all the ants? That's question number 1. Okay, and then question number 2 says about how many times more massive is it? So you have to find out which one is more massive, the total mass of all the humans, which would be the total number, and the mass. And if I'm trying to find that total number, I would be multiplying them. Or the total mass of all the ants. And again, I would be multiplying them. And then I am going to figure out how many times more massive that is. So again, we are estimating, okay? So if I'm estimating this and I'm looking at humans, I would be taking 7 and 5/10 times 10 to the 9th times, let's just say 6 times 10 to the 1st. And this is very similar to dividing them, and now I'm just multiplying them. So I'm going to use those same rules. I have coefficient numbers. I'm going to multiply those coefficient numbers. So 7.5 times 6, which would be 45. And then I'm going to pull the exponents, or the power of 10, and if I have the same base being multiplied, I'm supposed to add their exponents. So that would be times 10 to the 10th power. So this would be the total mass of humans. Then I'm going to do the same thing with total mass of ants. So I have 5 times 10 to the 16th times 3 times 10 to the negative 6. So I'm going to do 5 times 3, which is 15, times 10 to the 16th, times 10 to the negative 6, same base being multiplied. I add their exponents, so that would give me 10 to the 10th. So that would be the total of ants. So now I have the total for humans, which is here, 45 times 10 to the 10th. I have the total for ants, which is 15 times 10 to the 10th. And I now need to know how many times more massive, how many times more is my division. So I'm going to take 45 times 10 to the 10th divided by 15 times 10 to the 10th. 45 divided by 15 is 3 times 10, and then 10 minus 10 is 0. And we know anything to the 0 power is 1. So 3 times 1 is 3 times more massive. So this was a 3-step one. We had to multiply the human's number times its mass to find the total. We then had to multiply the ant's number times its mass to find the total. And then we divided them to find how many times more. I want you to pause this video, and then I want you to try number 4 on your own. And then when you're done, come back, restart, or don't restart the video, but hit play, and I will go over number 4 with you. Number 4, which is more massive, the total mass of all the krill or the total mass of all the blue whales? So similar to number 3, we have all of the krill and we have all of the blue whales, and we are going to multiply those two things. And in this one, we're really going to have to estimate because those decimals do not look very pretty. And then from there, we are going to figure out how many times more, which means I'm going to divide them. So let's start. And I'm going to figure out the amount of krill first. And then I'm going to figure out the amount of blue whale. That's the way that it's listed in the question. That's the way that I'm going to work through it. So I have amount of krill. If I'm looking at the number 7 8/10, I'm going to round that up to 8 times 10 to the 14th times 4 86/100. I am also going to round up to 5 times 10 to the negative 4th. I keep going just like I was doing before. I multiply the coefficient. 8 times 5 is 40. And then my power of 10, same base being multiplied. What do I do to their exponents? And I add them. So I have 10 to the 10th power. That would be for krill. Then I have the blue whales. I'm going to estimate those as well. So I would have 5 times 10 to the 3rd times 2 times 10 to the 5th. Multiply, and I would get 10 times 10 power of 10. I'm going to add them. So I would get 8. So I have the total number of krill and I have the total number of blue whales, and I'm now trying to figure out how many times more massive. So I'm going to divide 40 times 10 to the 10th divided by 10 times 10 to the 8th. 40 divided by 10 is 4. 10 to the 10th divided by 10 to the 8th is 10 squared. And 4 times 10 squared is then 400. So krill is 400 times more the total mass of blue whales. This is my walkthrough with you for activity 1, and switching between multiplication in scientific notation, division of scientific notation. Activity 2 is going to do the same exact thing with you. So I do want you to pause. I want you to go through activity 2. Activity 2 is just now on the solar system, so make sure you're paying attention to what it's asking and which numbers you are working with. So number 1, estimate how many Earth sides by side would have the same width as the sun. So you're looking for the diameter of the sun over the diameter of the Earth. Number 1, diameter of the sun over the diameter of the Earth. Number 2, estimate how many Earths it would take to equal the mass of the sun. So the sun's mass over the Earth's mass. Sun's mass over the Earth's mass. Number 3, estimate how many times as far away from Earth the planet Neptune is compared to the planet Venus. So the planet Neptune's distance from Earth divided by the planet's Venus distance from Earth. And last but not least, estimate how many Mercuries it would take to equal the mass of Neptune. So how many Mercuries it would take to equal the mass of Neptune. All right, I want you to pause the video, and then I would like you to come back and we can go over 1, 2, 3, and 4. All right, for activity 2, I'm going to walk you through each of them. If you have issues or you're not understanding, please make sure that you're writing it all down. Make sure you're pausing the video and figuring out where these numbers are coming from. So, activity 1. I'm sorry, question 1. So the sun is 100 times the width of the Earth. So the sun is about 300,000 times as massive as the Earth. Neptune is 100 times as far from Earth as Venus. And last but not least, it would take around 300 Mercuries to equal the mass of Neptune. All right, so that is activity 2. Activity 3 has us talking about professions. So for activity 3, I do want you to pause it here. I want you to go through. To save time, I have done these problems on paper and then uploaded their answers. So I'm not going to walk you through them step by step, but I am going to go over the answers with you. So here I need you to pause it, go through question 1, 2, 3, and 4, and then when you're ready, come back and hit play. For number 1, you're asked to estimate how many times more nurses there are than doctors. So I would take nurses and doctors, I'm going to divide them, and you're going to get about a half times 10 to the first power. Half of 10 would be 5. There's about 5 times as many nurses as there are doctors. Number 2, estimate how much money all doctors make put together. So you are going to multiply those two together. So I estimated again, I brought 6.9 down to the 7, 1 and 87 down to the 2, and then I just applied my exponent rule. You should get 140 billion, 14 times 10 to the 10th power. Number 3, estimate how much money all police officers make put together. So you are going to put those two pieces together by multiplying them. Again, estimating, I would have 8 times 6, which is 48, and then my exponent rule, 10 to the 9th, and that would be 48 billion. And last but not least, this is one of those 2-step problems, where actually 3-step problems. You had to find all enlisted military and all military officers, and then you had to estimate how many times more. How many times more is immediately that divide. So you had to find total, and then you had to how many times more. So enlisted, when you multiplied them and estimate, you should get 5 times 10 to the 10th power. For officers, when you multiply and estimate, you should get 2.5 times 10 to the 10th. And again, how many times more? That is the biggest clue here that I am dividing. I would have enlisted make 2.5 times more than all of the other officers. All right, the next area is your cool down. Take a second, pause it, put your work on a sheet of paper along with your name, and make sure that it gets into the inbox. You're estimating how many times larger 6 1/10 times 10 to the 7th is than 2 1/10 times 10 to the -4th. So go ahead and pause this. And then when you're done, you're going to come back and we have your learning targets. You are going to self-reflect, and then there was another handout that you picked up when you picked up your handout for this lesson today, and that other handout is actually one of your must-dos for menu math this week. So it is the must-do. You do need to complete it. It should be placed in your menu math folder when you are done, and then your menu math folder is to be put back neatly where they normally are kept. If you finish early and you still have time, you can go on to IXL and practice G1, G2, G3, any of the exponents, scientific notation, IXL lessons to help prep you for your test on Friday. My son is starting to feel a little bit better, so my assumption is that I will be in school on Wednesday. I will be here for parent conferences tonight. If your parents are coming, I will be there, and I will see you all soon. Thank you so much for working hard.